I don't think anyone can join. And today is Parents' Day. Everyone is busy with your parents, and many of them involved in classes, it seems. Okay. Yeah. So I don't want to, disturb you guys. Please let me know through the chat box if you have any issues and all. Okay. Sorry. Right. Okay. So, okay, guys, we'll let you, we'll discuss about the things which we are discussing in the last meeting. Yeah. So now I'll share my screen. I hope everyone can see my screen. Just let me check, cross check with my in the mobile. Okay. So I know many of you people have know about this substitution reactions, but still there is a, we want to do it and try to solve this homework question, guys. Very, very most important homework question. Try to solve this. Right. So take 2 minutes of time and try to solve this. Yeah. So if you understand, if you see this question, this particular question is undergoing free radical mechanism, right? So if this is undergoing free radical mechanism, I'm expecting from the YouTube, please do reply in the chat box. Okay. Good afternoon, Rajkot team. How are you? Guys, they joined a bit late. Please do reply in the chat box. Can you guys see my screen? Please do reply. My YouTube friends, any one of you, please do reply in the chat box. Guys, can you guys see my screen? Rajkot, please do reply in the chat box. Can you please? Yes. So the time is already up. I don't want to waste much time. So listen here very carefully. So upon looking to this particular question, what is BR2 in the presence of H nu? So this is ideally, we are talking about, yeah, so this is under sunlight. So this is under sunlight or UV light. I told you, whenever BR2 or any particular halogen gas is given, this is undergo free radical mechanism. It will undergo free radical mechanism. Okay. So this will undergo free radical mechanism. So there are so many products are there, A, B, C, D, which is the most suitable answer you have to pick it. So now the first of all, let me, yeah. So now see here very carefully. So the question is asking like this. Okay, you are having a double bond over here, and this is 6-member ring. And here you may get free radical, here you may get free radical, here you may get free radical, and here you may get free radical. So let's suppose giving the number 1, 2, 3, 4. So in the 4 areas, you may get the free radical, but you will not get the free radical in at the double bond. Why? Why you are not getting the double free radical at the double bond? The reason because here the bromine and bromine will undergo into propagation by forming 2Br radical. Okay, so 2Br radical it will go into form. So now how the free radical is forming here? By releasing one H free radical. So now this H free radical and here one Br radical will going to move as HBr. Now you are having one Br radical. Now these Br radical can undergo at the position 1, 2, 3, 4. But if you see very clearly, if it is undergoing at 1 or if it is undergoing at 4, both are same. Okay, the product you are going to get, both are same. Let's suppose if it is going at fourth position. So here you are going to get this. And if it is going at first free radical, here you are going to get Br. Okay. So now if you can observe here, if you are trying to name this one, both you are going to get the same name. So identical structures you are going to get. Simultaneously, second and third position free radical also, second and third position free radical also, you are going to get same product. How? I am going to draw here. So here you are getting Br, R, here you are getting Br, where at this particular position, Br you are getting. So both are same. So what is the name if you are going to call this one? So for this case, it is 1, okay, 2, 3. So this is called as 3-bromo cyclohexene. Cyclohexene, you are going to call it as, okay, 3-bromo cyclohexene, you are going to call it as. Here you can going to call it as 4-bromo cyclohexene. 4-bromo cyclohexene. Okay, so both are having same name. Now, which is the most stable product among these two? My dear YouTube friends, please do reply in the chat box. Among these two, which is the most stable product? Now, whenever the free radical is forming at this particular position, and if the free radical is forming at this particular position, at we can say at second position and at third position, you can say. So if the free radical is at second position, it indicates this is an allylic free radical. This is what? Allylic free radical. And due to conjugation, you can see pi sigma free radical. So due to the conjugation of pi sigma free radical, second one will have more stability over the third free radical carbon. So our ultimate product should be this, but not this. Why not this? Because the free radical stability will be at allylic position. So the carbon which got the free radical at allylic position, this will be more stable. So our product will be, if I see our product will be option C is the correct answer. And here also you will get the product. Yes, here also you will get the product, but this is minor one and this is major one. I hope you guys understand this. Sir, here you will get no, highly impossible. Is it possible? Yes. Option A is also possible, but you have to use excess of Br2. But I didn't mention excess of Br2. So that is why our major product will become this one. So the minor product will become this. So C is major and D is minor. So that is what we can learn from the free radical mechanism, yesterday's question. Now, if you see here very clearly, from the second question, you are having HBr and you are having an alkene. So I told you, whenever alkene is there and HBr is there, this will undergo addition reaction. What it will undergo? It will undergo addition reaction. So whenever it is undergoing addition reaction, what will going to happen? The H plus and Br minus you are going to get. H plus and Br minus you are going to get. Hello, JNV Sangli team. You are a bit late. Why you are late today? I know you all parents all came. You might be busy with them. Okay, but still no problem. We'll try to do best only. I don't want to bore you much. Okay, we'll go smoothly today. JNV Mahe team is also joined. Very good. Yes, in YouTube, anyone there? Any YouTube friends? Yes. So this HBr in the presence of alkene, it is always undergo addition reaction. It is always undergo addition reaction. So good afternoon, Sangli team. Yeah. So this will always undergo addition reaction. Now, addition reaction will undergo which product? That is undergo which mechanism? Markovnikov rule, right? Markovnikov rule. So what the Markovnikov rule telling? H plus will go where hydrogen contained carbon are more. Hydrogen contained carbon are more. So now you are having two carbons here, 1 and 2. Two carbons are there. So in these two carbons, where the hydrogen will go? That is the biggest question. Sir, here also carbons there. Here also double bonded carbons are there. Here also double bonded carbons are there. So if you write the ring with this, here also double bonded carbons are there. But still, why only you are telling at 1, 2, these two positions only hydrogen will go? The reason because Inside that, I again remember very carefully. Yesterday, one student asked me one question. We'll discuss this one in the upcoming slide. But now, when the HBr is there, the phenyl is acting as an electron withdrawing group. So the phenyl is acting as an electron withdrawing group. And here, the H plus and Br minus will be there. I told you H plus will go to the carbon where you are having more number of hydrogens. So H plus will go where? Where the H plus will go? Where the H plus will go? H plus will go where we are having more number of carbons. Okay. I hope you guys are clear with this. Where there is a more number of carbons are there H plus will go. I know in my screen, the option C is not visible. So let me give you an answer C. So let me draw option C here. For this particular question, option C is the answer. So if you see, this is the answer for for this particular question. If you are giving excess, then A will be the answer. If you are not giving the excess, C will be the answer. So this is our major product and that is our minor product. Why this is a major product? This is allylic bromide. Okay, allylic bromide is more stable because of conjugation. If you see pi, sigma, and yahan par free radical last time we got, so that's why pi sigma free radical. So that is why allylic free radical is more stable. So this substitution, or we can say the addition of Br is favors C as major and D as minor. Now you can see HBr. HBr is undergoing Markovnikov rule, where the H plus will go where we are having more number of hydrogen contained carbon. So this carbon you are having 2 hydrogens, here you are having 1 hydrogen. So now hydrogen will go here, and then Br will go on the second. So the ultimate product you are going to get. What is the ultimate product you are going to get? I am going to write benzene as simply phenyl. I don't want to waste much time. CH, and here you are getting Br, and here you are getting what? H. Why H is going here? Why H is going to this? Because of the Markovnikov rule addition reaction. In case if I am giving the peroxide here, the product will be pH, CH, and here you will get H, and here CH2Br. So this is the product you are going to get in case if you are having a peroxide. So this is without peroxide, and this is peroxide, that is anti-Markovnikov rule or Karash effect. We can also call it as. Okay, so I hope you guys understand. So now what is the IUPAC name of this particular compound? Tell me what is the IUPAC name of this compound. Guys, please do respond in the chat box. What is the IUPAC name of the compound? What is the IUPAC name? Tell me, what is the IUPAC name? CH, Br, and CH3. What is the IUPAC name? Mention in the chat box. What is the IUPAC name, guys? I'm giving the option A, 1 phenyl, 1 bromo, ethane. Okay. And option B, 1 comma, 1 bromo. Okay. 1 bromo, ethyl, benzene. Tell me among these two which is the correct answer, guys. Please mention in the chat box. Please mention in the chat box. If you are not mentioning, I am giving you the B. Are you sure? Rajkot team, are you sure? Okay. Yes. So B is the answer. Anyone with the answer? Anyone with A answer? Come on, do respond in the chat box. So this is homework for you. Let me tell you in the next class which option is the correct answer. Ask your CBSE teachers, ask your school coordinators. I don't want to answer this basic IUPAC question. I want you to ask your senior teachers or your friends, whoever it may be. And tomorrow, while coming, please do get a clarity on it. Right. So now today we are going to discuss about substitution reaction. So it's already 3:20. We are having another half an hour. Very pretty good, discussion session we can have. Substitution reaction. Ideally, why the substitution is taking place? Many a times there is a question that why we are having a substitution. So basically, if we are talking about substitution, okay, if I'm talking about substitution, so substitution is basically very easy concept, right? So that means whenever a strong person is going to displace the weak person, then you are going the substitution. Ideally, if you see in the cricket match players are going to substituted by the outside players. So this particular player can be substituted by this particular player. When the substitution is taking place, the player which is playing inside is weak, and if the other person is strong, then what he will do, he will substitute this particular fielder or player and he will come into action. Simultaneously, substitution reaction, especially for SN1, that is nucleophile substitution. What is that? Nucleophile. What is a nucleophile? Nucleophile is simply nothing but electron rich species. What is that? Electron rich species means it is having more electrons for the donation. So that is why we can call it as electron rich species. One of the example is Cn minus, OH minus, okay, and OCH3 minus. So these are the some of the nucleophiles. Okay, sir, only charged nucleophiles are there? No, this is, you can see H2O. Here it is having lone pair electrons. It can donate it lone pair. So that is, this is also nucleophile. So nucleophiles are basically which are ready to donate the electrons, and they are electron rich species, and we can also call them as Lewis bases. We can also call them as Lewis bases because they are ready to donate the electrons. Now, whenever the strong nucleophile is coming, here X is leaving as X minus. Here X is leaving as X minus because comparison between the nucleophile and living group, X is a living group, both are nucleophilic in nature, but the nucleophilicity or the stronger nucleophile is outsider nucleophile. If the stronger nucleophile is outside of the nucleophile, then it can easily displaces. It can easily displaces the X minus. So that is why you can clearly say that this nucleophile is attacking the R and becoming the product. So this is ideally a substitution reaction. Now you can see in this particular reaction CH3Cl. Okay, so CH3Cl in the presence of KOH, you are going to, this chlorine has been substituted by this OH. So now OH minus is more stronger nucleophile. Sir, how do you know which is a stronger nucleophile? Sir, you said that between Cl and OH minus is a stronger nucleophile. This is stronger in nucleophile. Can anyone tell me how OH minus will become a strong nucleophile? In the chat box, you might have read, right? You might have read in your schools how this OH minus is stronger than other. Tell me in the chat box. Why? Pretty simple, right? Why? Pretty simple. So the nucleophilicity is depending upon the, okay, so who are ready to donate the electrons. So here you can see the Cl minus is there and OH minus is there, and OH minus is more electronegative, and it will, we can clearly say that the electrons of hydrogen will pull B, and it can easily donate compared to chlorine. So compared to chlorine, OH minus is having negative charge and it is more electronegative. It will try to pull the electrons to itself. Simultaneously, Cl minus is less electronegative. So comparative to this, OH minus is going to give the electrons and you are going to get the product like this. Which displace other one will depending upon the electronegativity. Right. So now if you see the substitution reaction. So now we are going to study about the SN1 reaction. Sir, what is SN1 reaction? This is called nucleophilic substitution unimolecular reaction. Nucleophilic substitution unimolecular reaction. Nucleophilic substitution unimolecular reaction. So now, how this substitution, why we are calling it as SN1 reaction? Why we are calling it as SN1 reaction? Why? The reason because if you see here, SN1, the first step is the slowest step. Okay, so slowest step is also called as rate limiting step or rate determining step. So what is rate here? Rate is simply nothing but change in initial concentration minus change in final concentration minus change in initial concentration upon time. So let's suppose if you are having 0.5 moles are there, now it become 0.3 moles. So now the initial time is 0 second and this is 3 seconds. If I'm asking you the rate of this reaction, if I'm asking you the rate of reaction, then you will mention minus dc by dt. You might have studied in the chemical kinetics. Why you are writing minus dc by dt? Why you are writing minus dc by dt? Tell me. Because why we are keeping minus? If you see the change, you are getting minus negative 0.3 minus 0.5, you are going to get minus 0.2. So to avoid the negative change in concentration, we are keeping minus here for the reactant side. So now if you check this one, you are going to get what? 2 by 0.2 by 3. So this is the rate of the particular reaction. So 0.2 divided by 3 is the rate of the particular reaction. Simultaneously, if you clearly understand, my rate of a reaction is depending upon the concentration of the reactant. So now it depends upon the concentration of the alkyl halide. So now the rate of SN1 is directly proportional to the concentration of the alkyl halide. Okay, so concentration of the alkyl halide. So that is why we can clearly say that SN1 only one it will depending on only one molecule or one species. So that's why this is SN1 reaction. So we can also call it as rate determining step, or we can also say first order reaction. Now, whenever you got a carbocation, very most important. So first आपको क्या होने वाला है? Rx, and you are going to substitute by a nucleophile. So first step you are going to get R plus. Okay, first step you are going to get R plus. Now, whenever I am writing R plus, you are going to get a carbocation. You are going to get a what? Carbocation. So carbocation, it will try to be in the stability. Okay. So carbocation is trying to attain the stability. How it will get the stability? By rearrangement. By rearrangement. So just listen to this. So the order of stability of carbocation, I am going to write the order of stability of carbocation. So the order of stability of carbocation is first benzylic cation. What is that? Benzylic cation. So how do you write the benzylic cation? You just take the benzene and you just take one CH2 plus. So this is benzyl cation. Next one is allylic cation. Next one is allylic cation. So that is CH double bond, CH2 double bond, CH bond, CH2 Cl. I told you sp3 surrounded with sp2, okay, is called as allylic cation. So cation means here you will get plus and this will move away. So now why these both two? And next one is tertiary, then secondary, then primary, and then last but not the least methyl halide. So now why this benzylic cation is more stable? Why this benzylic cation is more stable? Very simple is if you just draw the structure. If you draw the structure, okay, so this particular carbon is getting positive charge, and here you are having a sigma, here you are having a pi, sigma, pi, sigma, pi, sigma, pi. So that means the conjugation is very high due to the delocalization of benzyl cation ions. Due to delocalization, or we can say conjugation in benzyl cation is the more stable than allylic cation. Again, allylic cation, if you see, I am going to write here CH2, CH, bond CH2 plus. So again, here you are having positive charge sigma pi. So whenever you are having pi sigma positive or pi sigma pi or pi sigma negative or pi sigma free radical, these are having more stability because they are having high, very good conjugation. Okay, so carbocation stability is completely depending upon what? Rearrangement, or you will have benzyl cation, then allyl cation, then tertiary, then secondary, and last but not the least primary and methyl halide. So this you people all need to be remember the stability of a carbocation. Right. Now we'll see the mechanism here. Now we'll see the mechanism. So what is going to happening? First step, Br will be removing and it will get a positive charge, that is tertiary butyl carbocation. And we know tertiary is more stable because of the 9 alpha hydrogens here. So because of that, So this next one is OH minus is the another nucleophile. OH minus is the nucleophile. This nucleophile will attack the carbon. So this nucleophile will attack the carbon. So then you are going to get a tertiary substitution product. Okay, but if you observe this one coming to the first step and last step, okay, coming to the first step and last step, there is a change. First of all, formation of carbocation is taking place. Next one is attacking the nucleophile. So we can clearly say that SN1 will undergo two steps mechanism. First one is formation of stability of carbocation, and second one is attacking of the nucleophile, and it belongs to the first order reaction. We'll study the different detail about SN1 while studying the differences between these two. Right. Next one is SN2. So now SN2 is a kind of very easy peasy reaction. Now why it is called as 2? Because my rate of a reaction is depending on okay, what? Nucleophile and simultaneously alkyl halide. So the rate of a reaction depends upon the nucleophile and the alkyl halide. So that is why if you count 1, 1, so the order of reaction is 2. So that is why we are going to call SN2. So SN2 is the order of reaction with rate, or we can say order of reaction 2. Okay, it is a substitution, nucleophilic substitution reaction. Clear? Now, how this mechanism is formed? How this mechanism will be there? In SN2 reaction, OH minus is a strong nucleophile. It will try to attach the carbon, and simultaneously there is a transition state. So what is transition state? Transition state is a state where the compound is highly unstable. So usually transition state will exist. No, they will not exist. But ideally, what are saying? Whenever the OH minus is approaching, Cl minus is leaving. Cl minus is leaving. So ideally, what we can clearly say from here is, my SN2 reaction is completely depending upon both the nucleophile and the alkyl halide. Okay, so now the nucleophile, how this nucleophile played an important role? How this nucleophile is playing important role? Tell me. This nucleophile, whenever it is attacking, it will attack the carbon, and simultaneously chlorine will leave as a leaving group. But whereas we will see about the products in the upcoming video, but now just understand this one. So it is very clear that SN2 is a bimolecular reaction. Why it is a bimolecular reaction? Because it depends upon the nucleophile and the alkyl halide, and it is a second order reaction. Why it is second order? Rate is directly proportional to nucleophile and the alkyl halide. And third, what is the third point? It forms a transition state. Which is highly unstable. And whatever the product you are getting, the product will be retention. Sorry, not retention, it is inversion. We can also call it as Walden inversion. For a CBSE exam, this is very, very most important. That means if let's suppose if you are having X, Y, Z, and let's suppose hydrogen, if the nucleophile is attacking, and if Y is a leaving group, then this will become what? C, H, X, and Z, and here you are having a nucleophile. So now nucleophile is attacking from the backside. Okay, so whenever the nucleophile is attacking, what is going to happen? This hydrogen, whatever it may be, X, Z, and Y will be completely removed. So these three will be moved aside. Why? Because of repulsions. Whenever the nucleophile is approaching the carbon, the other elements will try to deviate. So that's why you can clearly say from this one, this is a retained product. From the original one. So that is why it will show what? Retention. Retention. I hope you guys understand this one. If you are clear with this, please do tell me in the chat box. If you are clear, please do tell me in the chat box. Just a minute, guys. I'll just come. Okay, so a bit head. Just a minute, guys. Yeah, so a bit headache, so that's why I went. Now I'm back. So SN2 reaction is a both. It will depending upon the both nucleophile and the alkyl halide, and the final product is a inversion product. Okay, so it is actually inversion product. I am writing the retention. I'm sorry, that's why I went there. Okay, I'll erase this one once again. I'll tell you why we are going to call it as inversion and everything and all. We'll study it back later. Okay, so again I'll repeat the SN1 and SN2 reaction. So let me erase this stuff. Okay, just give me a time. I will again explain. So from what we are going to talk about. So if I am going to tell, let's suppose if I'm going to have an carbon X, Y, Z, and let's suppose this is R. Okay, so 4 different groups are attached. So now if any nucleophile is attacking, any nucleophile is attacking, first step, what is the first step? First step is the rate determining step. Let's suppose here X is a halogen. Here X is a halogen. After X is leaving, you are going to get what? You are going to get a carbocation. Now these carbocation, you have to check the stability first. You have to check the stability. So how do you check the stability? If it is a tertiary one, it will be more stable, then secondary, then primary, and then methyl halide. Okay, so the stability of an alkyl halide will be this one. So the stability of carbocation is also same. But another important thing you people need to remember, benzyl cation is more stable than allyl cation, then tertiary, then secondary, then primary. Sir, what is benzyl cation? Benzyl cation is very simple. You will have a benzene where CH2 will be attached, which is having a positive charge. Sir, what is allylic cation? CH2 double bond CH bond CH2 plus. So this is allylic cation. Tertiary, you already know, CH3, CH3, CH3. The carbon is attached with 3 different groups. So with positive charge, this is tertiary. And secondary is CH3, C, CH3, and H. You will get a positive charge. And next CH3, CH. I don't know why this will happen like this. Here I am writing CH3, CH2 plus. This is primary carbocation. Next methyl cation is simply CH3 plus. So this is more stable. So this is methyl cation. Okay. So another one is, this is the order of stability. So benzyl cation will be more stable than allylic, then tertiary, secondary, and primary. So this is you people need to remember, very, very most important. Okay. And next SN2, I told you it will attack, back attack. We can clearly say that this is a back attack. Back attack is taking place, and the carbon will get a pentavalent ion, pentavalent atom. The carbon will become pentavalent atom, which is highly unstable. So then you will get a retention product. So here you are getting a retention product. The rate is depending upon both the nucleophile and the alkyl halide. Clear? Now, this is the doubt. Last time who asked this doubt, guys? JNV, BD, or Washim or some school asked this doubt. Why does benzene not undergo a reaction with hydrogen halide? Can anyone tell me why benzene is not undergoing this one? JNV Varda is also joined. Come on, guys, in YouTube. Anyone is there who can answer this question? Why does not benzene undergo a reaction with HX? Pretty simple. Benzene is, will never undergo addition reaction. Benzene will never undergo addition reaction because these addition reaction will only takes place if there is a break, if there is a formation of positive charge and negative charge. But it is highly impossible forming a positive charge and negative charge inside a benzene. So that is why benzene will not undergo addition reaction. It will undergo only electrophilic substitution. It will only undergo electrophilic substitution, but there is no addition reaction. So that means Markovnikov rule will be not possible because there is no chance of forming positive charge and negative charge inside the benzene. I hope you guys understand the difference. Why benzene not go HX? Because it will not undergo addition reaction because there is no formation of carbocation inside of the benzene. But whereas electrophilic substitution can be takes place, that is you are taking Br, then you are going to get bromobenzene. If you are having taking Cl, then you are going to get what? Chlorobenzene. So like this, for aryl compounds we can form, but we can say that addition reaction will not going to happen. Only electrophilic substitution can be takes place. Right. So now, yes, this is another very most important. RS systems of the nomenclature. So these are called as configurations. So what is configurations? How we'll pretend in your examination, you may see R and S. I think most of them in your NCRTs, it was not there, but it is class 12th, class 11th concept also, and simultaneously very important for the exam. Now, if you see here, whenever you are having these kind of compounds, if they are asking what is the R configuration and what is S configuration, how do you determine which is R and which is S? Means based upon the molecular weight or atomic weight, based upon the molecular weight or atomic weight, okay, assign the numbers. So here you can see from these particular 4 compounds, 1, 2, 3, 4 compounds. Here iodine will get number 1 because the molecular weight of iodine is greater than bromine, then chlorine, and last hydrogen. So this is the molecular weight order. This is the molecular weight order. So when you got to know the molecular weight order, and when you assign the name, when you assign the numbering, just crisscross it, and try to see the rotation. 1, then 2. You can see here 1, then 2, then 3, then 4. Okay, so that means it is a what type of rotation? Clockwise rotation. And now see number 4 is on which line? Vertical line. If it is a clockwise rotation, and lowest number, highest number, or we can say lowest atomic weight, lowest priority group, or we can say lowest priority group is an horizontal vertical line, is on vertical line, then it is a R configuration. Let me tell you once again. So if you are having a compound iodine, bromine, chlorine, and you are having what here? Hydrogen. So the naming will be number 1 will be here, 2 will be here, 3 will be here. So just hold this one, then try to see the rotation. 1, 2, 3. So if you see this one, this looks like as a clockwise rotation. And if with the clockwise rotation plus lowest priority, that is hydrogen at vertical line. You can see this is vertical line. It is a vertical line. Then the configuration you are going to get R configuration. Next, simultaneously, if you see here, iodine, okay, here you are having, iodine, and here you are having bromine, and here you are having chlorine, and this your hydrogen. Now here you will get 1 and 2, 3. So again you are getting clockwise only. Again you are getting clockwise. So same 4. So this is clockwise, and lowest priority is at vertical line, clockwise rotation. Lowest position is at vertical line. This will show R configuration. Now we can say from here, okay, iodine, bromine, chlorine, and hydrogen. Now you see number 1 will get for the iodine, 2 for bromine, 3 for chlorine, 4 for hydrogen. Now you see the rotation here. This is anti-clockwise rotation. And the lowest priority or the lowest group is present where? Is present at the vertical line. So present at the vertical line. So this is S rotation. Okay. So now let me give you some examples here. Again, I'm going to summarize here. Okay, I'm going to summarize here. Clockwise rotation, lowest priority is at vertical line. Then this will become R configuration. Okay, next one, anti-clockwise rotation, lowest priority is at vertical line, and this will become S configuration. Just here 2 आप लोग indicate करना. So how do you find the priority order? Based upon the molecular weight. I hope you guys are clear with this. Okay, so now let me show you some of the examples. Try to answer this one. Okay. OH, CH3, Okay. So here you are having hydrogen and here you are having COOH. Okay, this is COOH. Now trying to answer this one. Sir, here carbon and here also carbon and here oxygen. So, okay, sir, oxygen is having more atomic weight. We'll give number 1 here. Very clear. Next, here carbon is there, here carbon is there. Who will give the number 1 priority? COH group will have number 1, number 2 priority or CH3? Tell me whose molecular weight is higher? COOH molecular weight or CH3 molecular weight? Tell me in the chat box. Whose molecular weight is higher? Tell me in the chat box. Whose molecular weight will be higher? COOH or CH3 now? Come on, guys. Tell me in the chat box. Molecular weight, I'm just asking. Obviously, COOH will have more atomic weight. When COOH is having more atomic weight, then the number 2 priority will go here and the number 3 will be here and number 4 will be here. What I told, just close the hand. यहाँ इस पे hand रख दो. Keep the hand here. Try to see the rotation. That is 1, 2, 3. So then this will go like this. 1, 2, 3. Anti-clockwise. Lowest priority is at vertical line, right? Lowest priority is at vertical line. Lowest priority is at vertical line. Now tell me what type of configuration it is. Tell me in the chat box what type of configuration it is. Tell me in the chat box. What type of configuration? RRS. RRS. Tell me. Yes, very good, Gujarat. So this is yes configuration. This is yes configuration. Okay. Now, just remember this one. Just remember this one. OH, CH3, COOH, and H. Okay. OH, CH3, COOH, and H. Now, it is very, very clear that number 1 will come here, number 2 will come here, number 3 will come here, number 4 will come. Okay. Now, if you see from here, again, keep your hand on this. Keep your hand. See the rotation. 1, 2, 3. So that means like this you are going. Again, you are going anti-clockwise. But now the lowest group. Now the lowest group is at horizontal line. Lowest group is at horizontal line. So remember, whenever the anti-clockwise is there, if the lowest group at horizontal line, earlier what is that? Anti-clockwise, we will show S configuration. But the lowest is at horizontal line, so then you convert them into R. So anti-clockwise, lowest priority is at horizontal line. We already know that anti-clockwise, it will give S configuration. But the lowest group is at horizontal line, convert them into R. So now this will become R configuration. So in your NCERT, it will look 1, 2, 3. So second position, R configuration. Like that, you people need to remember. Again, anti-clockwise rotation, that will usually show S configuration. But if the lowest group is at horizontal line, then S will become what? R. If the lowest group is at horizontal line, S will become what? R. Now, let me tell you again here. Now, let me tell you again here. Okay. So now see. OH. Okay. COOH. CH3 and OH. Okay. Next one is OH. COOH. CH3. Sorry, this is H. And this is H. Okay. Next one. This is JEE main question. Try to answer. CH3, okay, Br, H, Br, H, and CH3. First of all, try to give the IUPAC naming. So IUPAC are numbering. So COOH will give number 1, it will get number 2, it will get number 3. IUPAC. Okay. So for this second carbon, the carbon at C2 is a chiral carbon. Chiral carbon. So chiral carbon, it will show configuration. So now we need to say which configuration it is. Now we need to see which configuration it is. Which configuration? How do you know? Okay. Now see. It will get number 1 will get here. For the as per IUPAC, it will come here. But for the configurations, number 1 will here, number 2 will be here, number 3 will be here, number 4 will be here. Now tell me what is the rotation here, guys. Tell me what type of rotation it is. What type of rotation? Tell me in the chat box. What type of rotation it is? Tell me in the chat box. Clockwise or anti-clockwise? CW or ACW? Tell me in the chat box. ACW or CW? Tell me in the chat box. Yes. Anti-clockwise. So anti-clockwise. So anti-clockwise usually yes. But due to horizontal line is having what? Lowest group. Horizontal you are having lowest group. So now S will become what? Now S will become what? Tell me. R. So now what is the configuration of this one? This will become what? R configuration. Very good. So now this will become what? R configuration. What about this one, guys? What about this one? Tell me. 1, 2, 3, 4. Now, what is this is? This is what type of rotation? Clockwise rotation. Clockwise rotation usually R configuration. But horizontal line you are having lowest group. So R will convert into S. So as this is number 1 and number 2. Second carbon this is. So you are getting 2S configuration. And here you are getting what? 2R configuration. I hope you guys understand this one. If you are clear with this, please let me know through the chat box. If you are clear with this, please let me know through the chat box. Clear? Other students, please do reply. Other students, please do reply. Come on, guys, please do reply. Now, how to name this one? Let me erase everything so that we can do this question. Okay. Right. So how to erase? Let me erase this one. Okay. Take a screenshot if possible. If not, try to note down this one. Let me. Okay, let it be. I'll go to the next one only. Now I will erase this one. Now try to answer this. इसका आंसर कर लो आप लोग. Okay. CH3 BR and here I am so sorry, it is big line हो गया, थोड़ा बड़ा line हो गया. Okay, let me draw. BR CH3, here CH3 and here hydrogen is there and here hydrogen is there. Okay. Now try to give the numbering to this one. First, for this particular for this carbon, we are seeing the configuration. So this will give 1, 2, 3, 4. As per the IUPAC naming, this is from the IUPAC numbering will be like this. Now we are checking configuration for second carbon and third carbon. C2 carbon and C3 carbon. We are checking the configuration. How we are going to check the configuration? Let me change the color so that it will be useful for you. Yeah, now see in this case. So at second carbon, it is there. Now giving the configuration priority. First of all, here also carbon there, here also carbon there. Okay, so this is a different group. This is one group and this is another group. These three are another groups. So now tell me, which will give the highest priority first? Here carbon is there, here carbon is there, here bromine is there. I know bromine will get the most number 1 priority because higher atomic weight bromine. Now here carbon is there and here carbon is there. Which will you are going to get? Obviously, this carbon will get the number 2 because here only 3 hydrogens. But here we are having what? Bromine, hydrogen, and methyl. Next, you are going to get 3 here, and here you are going to get 4. Now the numbering is like this. Now the numbering is like this. That is Br, CH3, here CH3, Br, and here H, and here H. So this will get number 1, and this will get number 2, and this will get number 3, and this will get number 4. I told you, keep the hands here. Just see here, 1, 2, 3. What is the rotation, guys? What is the rotation? Tell me. What is the rotation? Clockwise rotation. Where the leaving group, where the lowest group is there? Horizontal line. So clockwise rotation is R. If the lowest group is at horizontal line, what is the configuration? R or S? Tell me in the chat box. What is the configuration? R or S? Tell me in the chat box. What is the configuration? If the lowest group, yes, very good. So then this will become yes configuration. Then this will become what? Yes configuration. So second is yes configuration. I hope you guys are clear. Now we will check for the third carbon. Now we'll check for the third carbon. Bromine, bromine, CH3, hydrogen, hydrogen, and CH3. Now, whenever you are checking for this one, again you will get number 1 here, and this carbon will get number 2, number 3, and this will get number 4. Now see what is the rotation here, guys. Now see what is the rotation here. What is the rotation? 1, 2, 3. Correct. So this is anti-clockwise rotation. Lowest group is at horizontal line. So anti-clockwise is yes, but the lowest is at horizontal line. Now the configuration. Third carbon configuration, what will going to happen? Third carbon configuration, what will going to happen? Tell me in the chat box. Tell me in the chat box, guys. What will be the configuration? Anti-clockwise is yes, but the lowest group is at horizontal line. Now what will be the configuration? R configuration or S configuration? Tell me in the chat box. Yes. Now this will become R configuration. So the third will have, carbon will have R configuration, but the second is having what? S configuration. So the answer for this question is 2S, 3R. The answer is 2S, 3R. So this is JEE mains question, guys. I hope everyone will understand the configuration. Is it clear to you all? I hope it is clear to you all, my dear YouTube friends. Okay. Okay, guys, we'll see you in the next week. Thank you so much for joining. I hope you all enjoyed the food that your parents bought. Okay. Good luck, guys. See you in the next week. Bye-bye. Bye, YouTube friends. How is the class today? Please do reply in the chat box. How is the class today? Yeah, thank you, my team. Thank you, Rajkot. Bye, guys.